Half the world's AI coding traffic now runs on models most people have never heard of, not the American labs everyone argues about. A wall of Chinese open-weight models, quietly eating the meter. On the open router that developers actually piped their code through, these models reportedly went from a rounding error to somewhere north of 45% of all tokens. Not a headline, a takeover you can measure, and the model sitting on top got there by lying. It stealth-launched under a fake name, dressed up to look like a DeepSeek release, and climbed the charts before anyone clocked what it really was. So I did the obvious thing. I pulled Claude out of my daily workflow for a week and ran everything on these instead. Here's what actually happened, and the one job I still won't hand them. Here's the map, how the flip happened, and whether the numbers are even real. The number one model that faked its way up, why switching is suddenly easy, my actual week running on them, and the one job I keep at home. Start with the thing nobody's looking at. There are two scoreboards in AI. The loud one is headlines. Which lab shipped the smartest model? The quiet one is the meter. Whose models people actually run, token by token, all day. And on that quiet meter, the one measuring real usage instead of press releases, the balance tipped. The models doing the most actual work stopped being the ones getting the most coverage. The trajectory, as reported by the trackers, is almost comical. A little over a year back, these open-weight models were about 1% of tokens, then roughly 10%, then about 25%, now past 45%, with some counts pushing higher. I'm hedging that number on purpose. These are live market figures that move week to week, and different trackers cut them differently. But every source I checked points the same way, up and to the right, fast. Quick plain English on the router, because it's the whole mechanism. It's a middleman service. Developers point their app at it once, and it forwards each request to whichever model they pick. So it sees the traffic, and that traffic is the meter I keep pointing at. And here's why it matters to anyone who writes code. On that router, programming is now more than half of everything people use it for. This isn't chatbots for fun. This is real engineering work, quietly rerouting. So step back on what this means. The story everyone tells is a two-country race for the smartest model. The meter tells a different one, where compute actually gets spent. A wall of cheap, open Chinese models is already carrying a huge share of the load, largely unnoticed. The names are ones a lot of people outside the weeds haven't clocked. MiMo, GLM, Quen, DeepSeek. Open-weight models you can download, run, or rent for a fraction of what the frontier costs.
Now the part that sounds made up. The single biggest model on that meter, by reported token volume, isn't from a lab you'd guess. It's MiMo, from Xiaomi. Yes, the phone company. By the tracker's count, it's pushing something like 4.65 trillion tokens a week. That's not a niche. That's more raw usage than models with 10 times the press behind them. And a lot of these are open weight, which is the real story under the story. The weights are public. You can download them, run them on your own hardware, or rent them cheap from a dozen providers. That's why the price collapsed and usage exploded. And how one of these got to the top is the spicy bit. It didn't launch with a flag on its back. It showed up stealth, under a hunter-style codename, dressed to look like an upcoming DeepSeek release. People assumed it was DeepSeek's next thing, so they tried it, ranked it, hyped it. By the time the mask came off and the real provenance came out, it had already climbed. It bought its reputation on a borrowed name. And it's not a toy. On programming specifically, that one family reportedly accounts for something like a fifth of all the coding tokens flowing through the router. One model, a fifth of the code. Hold on to that mask for a second. A model that faked its own identity to win is genuinely impressive engineering. It's also, later in this video, exactly why I won't hand it everything. But first, is it any good?
So why can a regular developer flip half their stack to these overnight? Because of the thing in the middle of all this, the router. One account, one endpoint, and you can aim your code at almost any model by changing a single line. Setting up my week took about 5 minutes. I pointed my existing agent at the router, changed the model field, and left every other piece of my setup exactly as it was. If it went badly, changing it back was one line too. That low stakes is the whole point. Then two curves crossed. The open-weight models got genuinely good at code, closing most of the gap that used to make them a non-starter. And their price stayed a fraction of the frontier, routinely 10 to 20 times cheaper per token. And the reason the price is this low isn't magic. When the weights are open, any provider can host the same model, so they compete on price to the floor. Add labs that are happy to run thin margins to win share, and renting these gets absurdly cheap. I want to be square about capability. On the hardest, most tangled problems, the frontier models are still ahead. That gap is real, and I'm not pretending it closed. But most work isn't the hardest problem. Most work is the middle, and the middle is where good enough and cheap wins. Here's the mental model I want you to keep. Don't track who has the smartest model. Track where the tokens go. Capability gets the headlines, but price and good enough decide what actually runs at scale. And on both of those, the balance moved. Because for a huge slice of everyday work, nobody needs the single best model on Earth. They need one that's good enough and cheap enough to run constantly without watching a meter. That's the door these models walked through.
Enough market talk. Let me show you the one test I actually ran, so this isn't just charts. I took a real chunk of my own code, a roughly 300-line module that parses messy input, and gave the exact same job to 3 models. The job was identical in every lane. Break up one overgrown function, add proper error handling, and write tests that pass. Claude was my baseline, the model I trust and know cold. The 2 Chinese models were the challengers, and I logged 3 plain things: what it cost, how long it took, and whether the result was actually good. Did the tests pass? Did it handle the edge cases? Would I ship it? No secret scoring, just the stuff that decides whether I'd switch. Cost was the part that made me sit up. The baseline run cost what a baseline run costs. The 2 challengers did the same task for what felt like loose change, roughly 1/10 of the spend, give or take, across the week. I'm rounding on purpose. Speed was close enough that I stopped noticing. On a task like this, all 3 landed in the same rough ballpark. Nothing about the switch made my day slower, which honestly surprised me going in. Quality is where I expected them to fall apart, and mostly they didn't. MiMo split the function cleanly, wrote tests that passed, and the structure was close to what I'd have done myself. One tricky edge case needed a second nudge, but so does the baseline some days. It wasn't all clean, and I want to be honest about the rough edge. On one pass, a model confidently invented a helper that didn't exist in my codebase and wired the tests around it. It looked right, it wasn't. My own checks caught it, which is exactly why you never skip them. One correction later, it fixed it, and the tests went green. And here's the fair part. My trusted baseline pulls the same stunt some days. Confident, wrong. Caught by verification. That failure mode isn't a Chinese model thing. It's an every model thing. GLM got there too. A little more verbose, a little more hand-holding on the error handling, but correct. If you'd shown me the 3 results with the names stripped off, I could not have reliably picked which one came from the expensive model. And that's the honest headline of my week. For everyday building, refactors, tests, glue code, the unglamorous majority of the work, these ran neck and neck with my trusted baseline at a fraction of the cost. As a pure cost decision, switching most of my work over was a no-brainer. And that one refactor wasn't the whole week, it was the measured test. Around it, I ran my normal grind on these models, small fixes, throwaway scripts, first drafts of docs. Day to day, I mostly forgot I'd switched, which is the highest compliment I can give a swap like this. One caution, out loud. I'm giving you rounded, qualitative numbers from my own bench, not a lab benchmark. The precise cost and timing receipts get captured on screen before this ships. Treat these as one operator's week, not a leaderboard. So if it's this good and this cheap, the video's over. Switch everything, right? No. Here's the honest part, and it's the reason the whole switch has a hard edge. There's exactly one kind of work I still won't send to them. Anything sensitive, client code under an agreement, production secrets, a private code base that isn't mine to leak. That work does not go to these models. Not because they're bad, because of where the request goes and who I'm trusting with it. When you hit these through a hosted router, your code leaves your machine and runs on someone else's, often under a different country's rules on data and retention. For my own throwaway experiments, I don't care. For someone else's confidential code, I care a lot. And to be specific about the risk, because it's easy to get shrill here. It isn't the model is spyware, it's mundane and real. Your prompt and your code become a request logged on infrastructure under rules you didn't write and can't audit. Then remember the mask. The single most used model on that meter got to the top by lying about its own identity. That's clever marketing. It's also a straight-up trust tell, and I'd be silly to ignore it. If a team was comfortable disguising what their model was to win a leaderboard, I'm not going to assume perfect transparency about what happens to the code I send it. That's not paranoia. It's the same rule I'd apply to any vendor that opened with a costume. So the line I settled on by the end of the week is simple. My own code, open source work, experiments, throwaway scripts. Send it, save the money, no hesitation. Anything confidential, or anyone else's, keep it on a model and a jurisdiction I'm willing to stand behind. There's a smaller catch too. This world moves weekly. Models get renamed, re-ranked, quietly swapped, sometimes pulled. Whatever's top of the meter right now might not be in a month, so treating any single one of them as permanent infrastructure is its own mistake. But notice how narrow that caveat is. It doesn't undo the switch. It carves out one bucket. For most of what most developers do all day, the cheap, good enough, open weight option is now genuinely the pragmatic default. You just don't hand it the crown jewels.
If you want the operator take on what's actually worth switching to in AI, test it on real work with the honest caveat attached. Subscribe. I run the thing myself and tell you where it wins and where it bites. Fast recap. The scoreboard that counts real usage flipped. On the open router developers actually run code through, Chinese open weight models reportedly went from about 1% of tokens to north of 45%, and still climbing. The quiet number one is MiMo from Xiaomi, at a reported few trillion tokens a week, and one of these models climbed the charts by stealth launching under a fake DeepSeek-style name. Impressive and a trust tell. I gave one real refactor to 3 models. On cost, the Chinese ones ran at roughly a tenth of my baseline. On speed and quality for everyday work, I honestly couldn't tell them apart with the names hidden. So the verdict: for most of your work, switch. It's good enough and a fraction of the cost. Just keep one bucket back. Anything confidential or anyone else's code stays on a model and a jurisdiction you'd defend. That's the one thing I won't send. Half the meter already switched without asking your permission. Now you know what's behind it, what it's good for, and the one job to keep it home. Stay in the loop. See you in the next one.